Hi, everybody. Mr. Rubo here. And today we're going to continue with looking at rational functions, kind of pulling out the important things. And yeah, then you guys are going to get some practice. And yeah. We're looking at page 5 on the notes. And you'll end up doing 5 and 6, and then 7 is a nice reference guide. But yeah, we're going to look at number 1 here. So they want us to do all the stuff you guys did last week or last class. So once you determine the domain, write in reduced form, name all vertical asymptotes. Then part 2, name horizontal oblique asymptotes, the y-intercept, and x-intercepts. So it's written in this order for a reason. You want to do these kind of in this order every time. Okay. So here, determine the domain, we start with that because the domain is determined from the original equation, and it's specifically from the denominator. So my domain is that x such that x cannot equal, and the nice thing here is it's factored for us in the bottom already. If the bottom wasn't factored, we'd have to factor it. Okay, so because it's factored, okay, you can just go to each factor, set them equal to 0, and solve them. So x plus 5 equal to 0, subtract 5, you get negative 5. X minus 3, add 3, you get positive 3. X plus 3 equals 0, subtract 3, you get negative 3. Usually I like to write them in numeric order. So lowest to highest, and there's our end bracket, and there's your domain. Okay. Now for part B, part B wants us to write in reduced form, which literally just means is after you factored it, after you written the domain, look at the numerator and denominator, and if you see the exact same factor, then cancel them out. In this case, you'll notice I put those parentheses there because it was the only thing on top. So because of that, I'm going to cancel this out. Okay, so reduced form, so let me write A, B is going to be r of x equals, since everything went away in the numerator, I just am left with a 1. And then x plus 5, x plus 3. Okay, so we cancel that out. Now, this thing will tell us, what we canceled out will tell us something important. We're not going to talk about it quite yet, but just to kind of put it, kind of foreshadow things, that's going to help us find our hole or our removable discontinuity. Okay. So the next step is to name all verticals. Okay. Well, we have to do it after the reduced, because when we reduce, what cancels out is our hole. What's left over in the denominator is our verticals. So our two VAs are going to be, you set x plus 5 equal to 0, so you solve it. So x equals negative 5, and then x plus 3 equal to 0, solve it. X equals negative 3. And you'll notice I put x equals in the front of both of them because these are vertical lines. Vertical lines are in the form x equals a number. If you don't write x equals a number, you are not telling me a vertical. You're not telling me a line, a vertical line. You're just telling me a number, which we don't want that. Okay. So then, kind of moving along, now we're to part 2. So part 2 is now name the horizontal or oblique. So that's where you look at the degree on top versus the degree in the denominator. So degree numerator, degree in denominator, compare them first. If the degree on top is smaller than the degree on bottom, and you can actually do it from either the original or the reduced, so it's kind of up to you. I like to always use the reduced, but it's really up to you. So for this one, if you look at the reduced, degree on top is 0. Degree in the numerator is 0. Degree in the denominator, well, there would be a quadratic, so it's degree 2. Okay, and if you recall, you look at what's on top versus what's on bottom. If the numerator is smaller, your horizontal is y equals 0. Okay, if they were the same, if they were like both degree 2 over degree 2, then it's y equals the leading coefficient over leading coefficient. We didn't have that here, but again, if it does come up, that's what you do. And then oblique happens when the numerator is 1 higher. Okay, and to find the oblique, you'd end up doing some long division or synthetic division depending on what you have, but we don't have that here, so we don't have to worry about it. So yeah, so now let's keep it going. Y-intercept. Y-intercept is substitute 0 in. Now you do have to make sure that you can substitute 0, because sometimes in the domain you might not be able to. If it says you can't equal 0, then your answer is none. If you can, though, then substitute in 0. And I would do it in the simplified one, and I'm just making that look a little nicer. 0 plus 3. So if you simplify this, you get 1 over, that's 5. That's supposed to be 0 plus 3. So you get 1 over 15, which means the y-intercept is 0, comma 115. Okay, and yes, you will deal with a lot of fractions. That's part of these functions. They are fractions, which means fractions are very common in what you get. All right, and then the last thing you do is that x-intercept. So for x-intercept, you go ahead and go to the reduced, and you set the whole thing equal to 0. Now, there is kind of a shortcut. Not kind of, there is a shortcut that you will see, because you set it equal to 0 and you start solving. Well, what you're going to do every single time is your first step is to multiply both sides by the denominator. Okay? Well, when you multiply by the denominator on the left side, you get just the numerator, so you get 1. On the right side, when you multiply by the denominator, you get 0 times anything, which means you get 0. So you'll notice you just take the numerator, set it equal to 0 to find the x-intercepts. You'll notice there is no x here, which means there is no x-intercept. So there means you have none. Okay. If it was like x plus 7 equals 0, then you know that you'd solve that for x equals negative 7. Okay. That would be your x-intercept. But in this case, we have none. Okay. So go ahead and try out these problems, the rest of these. They, lots of parts, but honestly, the math itself is not horrible. You will have to do some factoring for these ones, but you got all those ones, and then there's a couple here. If you keep forgetting certain things, maybe put some notes down here, but then also go on to page 7 if you get stuck again, especially when it comes to the degree. So by proper fraction, they mean the degree on top is smaller than the degree on bottom. This is when they're the same. This is when it's 1 greater. Okay. So yeah, thanks for watching and have a good day.